So today the lab of DSP is moving average filter FIR filter using Fourier transform design method, and the objective of this lab is to implementation and analysis of moving average filter, implementation and analysis of finite impulse response filter using Fourier transform design method. So the task one of this lab is to define filter, types of filter, what are the time domain parameters for a filter, and what are the frequency domain parameters for a filter. And the last is discuss the role of low pass filter for filter designing. So here is we have to define a filter. A filter is a system that processes a signal in some desired manner, often to remove unwanted components, enhance certain aspects, or extract specific information. Part B is types of filter. Filters can be categorized based on their frequency response. Low pass filter passes low frequency components and attenuates high frequency components. This is the low pass filter. High pass filter passes high frequency components and attenuates low frequency components. Band pass filter passes a specific range of frequencies and attenuates frequencies outside this range. Band stop or notch filter attenuates a specific range of frequencies and passes frequencies outside this range. Next, part C is time domain parameters for a filter. Time domain parameters include the impulse response, the output of the filter when the input is an impulse. This is the impulse response, and the step response is the output of a filter when the input is a step function. Part D is frequency domain parameters for a filter. Frequency domain parameters include frequency response, describes how the filter modifies each frequency components of the input signal. Magnitude response, the magnitude of the frequency response. Phase response, the phase shift introduced by the filter at each frequency. Next, the last part is role of low pass filter for filter designing. A low pass filter is often used to remove high frequency noise or unwanted high frequency components from a signal, allowing smoother signal reconstruction or feature extraction. Next, task number two for this lab is to plot the signal in time and frequency domain along with its magnitude response. And this is the signal. And the part B is apply three taps symmetrically around moving average filter on signal X less noise and observe the frequency time and frequency domain parameters. Next, part C is apply 11 taps symmetrically around moving average filter on signal X noise and observe the time and frequency domain parameters. Next, part D is apply 25 taps symmetrically around moving average filter on signal X noise and observe the time and frequency domain parameters symmetrically around the moving average filter. And this is the equation for this, and you may use this function to observe frequency domain parameters. So here is the MATLAB code for the task number 2, and the output of this code is this. Next, we have to implement task number 3 in MATLAB. Uh, Part A for this task is repeat example 7.2 with 7 tap, 17 tap, 51 tap, and 101 tap. Observe the frequency domain parameters. Here is the example. Calculate the filter coefficient for 3 tap number of coefficients FIR low pass filter with a cutoff frequency of 800 Hz and a sampling rate of 8000 Hz using the Fourier transform method. Next, part B is determine the transfer function and differentiation of the designed FIR system. Compute and plot the magnitude frequency response for omega equal to 0, pi by 4, pi by 2, 3 pi by 4, and 5 radian. And the part B for this task is apply the filters made in part A to the signal X signal. Observe the changes for signal X in time and frequency domain while varying number of coefficients of the filter. Note, applying filters on a signal is convolving filter coefficient with the signal. So here is the MATLAB code for the task number 2, and the output of this task is this. So the last task for this lab, that is task number 4. Repeat example 7.3 with 7 tap, 17 tap, 51 tap, and 101 tab. Observe the frequency domain parameters. This is the example 7.3. Calculate the filter coefficients for a 5-tab FIR bandpass filter with a lower cutoff frequency of 2000 Hz and an upper cutoff frequency is 2400 Hz with a sampling rate of 8000 Hz. The part B is determine the transfer function and plot the frequency responses with MATLAB. The part B is apply the filters made in part A to the signal X signal. Observe the changes for signal X time and frequency domain while varying the number of coefficients of the filter. So here is the MATLAB code for the last task of this lab, and the output of this task is here.